Our next section, 9.4, we're going to talk about inverse trigonometric functions. So the three functions that we have on our calculator to do inverse trig on are inverse sine, inverse cosine, and inverse tangent. And what I want you to realize is the inverse trig functions, actually those should be a's, not thetas. Inverse trig functions actually give us an angle. So, key point to remember is inverse trig functions give you an angle. One thing that I want to warn you about is our inverse trig functions, our calculator is only going to give us answers in two quadrants. And that's because in order to make the function so that it has an inverse, which we're going to do when we talk about graphing them, we'll see this graphically, I need to restrict this to two quadrants. So the inverse sine function is restricted to quadrants 3 and 4. So if you're doing the inverse sine of a positive number, you're going to get an angle in quadrant 1. And if you're doing the inverse sine of a negative number, you're going to get an angle in quadrant 4. Okay? For inverse cosine, it's in quadrants 1 and 2. Inverse cosine of a positive number is in quadrant 1. Inverse cosine of a negative number is in quadrant 2. Similarly, inverse tangent is going to give you inverse tangent of a positive number is in quadrant 1, and inverse tangent of a negative number is in quadrant 2. There are going to be some problems that we do where you're actually going to have to find things that are in quadrants that your calculator doesn't give you an answer. So you're going to have to draw the angle and then figure out how do I transfer that angle so that it would have the same sign in one of the quadrants that I don't get the answer for. So easiest way to do this is with some examples. So first thing we want to talk about is remember that the inverse trig function of a number gives me an angle. So what the question here is asking is what angle has a sine of square root of 2 over 2? What theta has a sine of square root of 2 over 2? And this is where having your unit circle memorized is going to come into play. Well, I know that the square root of 2 over 2, okay, one, it's positive, so it's going to end up in quadrant 1. Square root of 2 over 2 comes from a 45-degree angle. So my answer is 45 degrees. And we also need to be able to do that in radians, so that would be pi fourths. Second example, what angle has a cosine of 1/2? Cosine is the x-coordinate, so I need the angle that has the short side, because 1/2 is the short side of my memorized angles. So that would be a 60-degree angle. And we know that 60 degrees is pi thirds. What angle has a tangent of -1? So that's when sine and cosine have the same values, and that would be at a 45-degree angle. But it's negative, so that would be down here in this quadrant. Okay, so my answer is going to be a quadrant 4 angle. Okay, that quadrant 4 angle is going to be the negative 45 degrees. Or negative pi fourths. Next one, what angle has a sine of -1/2? Sine is the y-coordinate, so it's the y is the short one in the negative direction. So that would be a negative 30 degrees because it's the shallow angle. Or negative pi sixths. I'm going to pause the video really quick and change out my microphone. So one thing I'm going to add to the three drawings that I have here are what your acceptable answers are if they just ask you for the inverse trig function and don't give you any further restrictions. So the inverse sine of A is going to give me an angle between negative 90 degrees is less than theta, which is less than 90 degrees. Or negative pi halves I will put less than or equal to here, is less than or equal to theta, which is less than or equal to pi halves. For inverse cosine, 0 degrees is less than or equal to theta, which is less than or equal to 180 degrees. In radians, 0 radians is less than or equal to theta, which is less than or equal to pi radians. For tangent, it's negative 90 degrees is less than, I can't have a less than or equal to because that would be dividing by 0, 90, and negative pi halves is less than theta, which is less than pi halves. So these are the ranges of your inverse trig functions. The domains of your inverse trig functions, so these are your ranges. Your domains of your inverse trig functions are from negative 1 to 1 for sine, inclusive, negative 1 to 1 for cosine, and from negative infinity to infinity for inverse tangent. So the domains from negative 1 to 1, negative 1 to 1, and negative infinity to infinity, and these are the ranges of my inverse trig functions. So let's go back and do 3 more examples really quick, and then I will show you how we apply this in triangles. So what I have here for the 4th example is the cosine of theta is equal to 0.4. And then it tells me my angle has to be between 270 and 360. So what I'm going to do is I'm going to rewrite that equation. And then I'm going to show you my thought process on how I go about solving it. So I'm going to write cosine of theta is equal to 0.4. I don't want the cosine of theta, I just want the angle theta. So what I'm going to do is take the inverse cosine of both sides. Okay? Two functions, a function and its inverse performed consecutively cancel each other out. And now I put that into my calculator. Make sure, let's do this one in degree mode because they gave me my restriction in degree mode. So I'm going to take the inverse cosine of 0.4, and it gives me approximately 66.4 degrees. But I need to look, and it told me, hey, it wants the angle between 270 and 360. So what does that mean for me? It means for me, I need the angle in quadrant 4. Let me try to draw it as a 60-ish. That has a 66.4 degree reference angle. I need this one right here, which is negative 66.4 degrees. Okay, that is a quadrant 4 angle, but it does not fall between 270 and 360. So what I'm going to do is I'm going to take 360 minus the 66.4 degrees, and that's going to give me my answer. So 360 minus 66.4 is approximately 293.6 degrees. So you can't just rely on your calculator. You actually have to use some reasoning to make sure your angle is within the correct range for the desired answer. So let me write down the answer here. We said approximately 293.6. The next example, it says the sine of the angle is negative 0.23 degrees. So it says the sine of theta is equal to negative 0.23. It's not degrees, it's just negative 0.23. So what I want to do is take the inverse sine of both sides. Okay, these cancel each other out, so I'm going to get theta is equal to the inverse sine of negative 0.23. That's a calculator problem. Inverse sine of negative 0.23 is negative 13.3 degrees. So what I'm going to do is I'm going to draw that angle. And then I'm going to look to see what they wanted the answer in. They wanted the answer between 270 and 360. Yes, I have a quadrant 4 angle, but I have the wrong one. So what I'm going to do is I'm going to take 360 minus what they gave me, what I got by calculation. So 360 minus 13.3, and I get 346.7. Which is this angle that has the exact same terminal side as the negative 13.3 degrees. The next example is they tell me that the sine of theta is equal to 0.62. So if I want to find out what the angle is, I'm going to take the inverse sine of both sides. Inverse functions performed consecutively cancel each other out. So I get theta is the inverse sine of 0.62. That is a calculator problem. And I get 38.3 degrees. So what I need to do now is draw the angle, because they want me to have an angle between 90 and 180. 38.3 degrees is not between 90 and 180. So, if I draw my 38.3 degree angle, I want an angle that's in quadrant 2 that has the same y-coordinate. Well, if it's in quadrant 2 with the same y-coordinate, I know that this angle right here is going to be 38.3 degrees. So in order for me to come up with my desired angle, which is this one, I'm going to take 180 minus the 38.3 degrees. And that's 141.7 degrees. $141.7 degrees. Now let's talk about which ones are calculator problems and which ones are memorized problems. Anytime that you're doing the inverse sine or inverse cosine of the following numbers, 0, 1, 1/2, square root of 3 over 2, or the square root of 2 over 2, you will give me, that's a non-calculator problem. Anytime that you are doing the inverse tangent of 1, 0, square root of 3 over 3, or the square root of 3, those will end up being memorized ones. And I expect you to be able to come up with both degrees and radians for these memorized inverse trig function values. You get these by looking on the unit circle in the correct quadrant to come up with your answer. Okay? Let's look at inverse tangent really quick. So we're going to do our 3 tangents. The first tangent is the 30-degree angle, which is 1, 2, square root of 3. So tangent of 30 degrees is equal to 1 over root 3, which is the square root of 3 over 3. Our 45-degree angle has 1, 1, and the square root of 2. So if this is 45 degrees, the tangent is 1. And then our 60-degree angle, we have the square root of 3, 1, and 2. So I get the square root of 3 over 1. So here's the thing I want you to notice. That if it's the small angle, I get the smallest number. If it's the medium angle, I get the medium number. And if I get the large angle, it's the large number, positive or negative, depending upon which quadrant I'm in. And the tangent of 0 degrees, using my unit circle definition, is 0. So that's where I got those 4 values of tangent that you need to be able to go backwards. So the inverse tangent of 0 is 0. Inverse tangent of square root of 3 over 3 is 30. Inverse tangent of inverse tangent of 1 is 45. Inverse tangent of square root of 3 is 60 degrees. So I'm going to pause the videos and do some examples on how we use the inverse trig functions with triangles. So I have 3 triangles here. I give you 2 sides of the triangle and I tell you which angle I want you to find the measure of. So for any trig problem, first thing I want you to do is I want you to circle the angle of interest. Label the sides. We always label the hypotenuse first. The other side that touches the angle is the adjacent. And then we have the opposite. And then what I'm going to do is I'm going to figure out what I have and which trig function that is to write my equation. So I have adjacent and hypotenuse. The trig function that has adjacent and hypotenuse is the cosine. So I write the cosine of theta is equal to adjacent over hypotenuse, 4/9. Then you're going to take the inverse trig function of both sides. So I'm going to take the inverse cosine of both sides. On the left, I'm going to get theta. On the right, I'm going to get the inverse cosine of 4/9. I put that in the calculator. And I get approximately 63.6 degrees. So again, you circle your angle. You label your sides. Hypotenuse, the other one that touches is adjacent. Last side is opposite. Figure out what you have. I have adjacent and opposite. I know that opposite over adjacent is the tangent. So the tangent of theta is the opposite over adjacent. Take the inverse tangent of both sides. So I get theta is equal to the inverse tangent of 5/4. I just simplify the fraction. Stick that in the calculator. Inverse tangent of 5/4 is approximately 51.3 degrees. Circle the angle of interest. Label the sides, hypotenuse. Other one that touches is adjacent. Last side is opposite. Figure out what you have. I have opposite and hypotenuse, which is sine. So I know the sine of the angle is equal to 5/12. Take the inverse sine of both sides. That tells me that theta is equal to the inverse sine of 5/12. Put it in the calculator, and I get theta, 5/12, is approximately 24.6 degrees. So the half sheet that I am going to give you is going to have the following problems on it. It is going to have problem number 7. And it is going to have problem number 27 out of the homework for section 9.4. So if you are not here on the day that I assign the video, you need to do problem 7 and problem 27 on page 582. These will be the ones I check at the beginning of class as part of your notes. Remember that all the examples need to be in your notes also. Thanks.